Okay, we have to calculate the mass of mercury. So what will be the reaction in this case? So we will have a reaction HgO. So HgO is heated. So if you heat HgO, this will break into Hg plus half O2. This reaction you have to remember, then only you can solve this problem. So this is Hg plus half O2. And this Hg is a liquid and O2 is a gas. And HgO is given in the problem or not? If nothing is given, let us assume this is a solid. Now what is the delta H for this reaction? We can calculate. Heat of formation is given. So on the basis of heat of formation value, we can calculate delta H. So delta H, F degree of product minus delta F degree, summation of delta H of product minus summation of delta HF degree of reactant. So this will give you heat of reaction. Are you getting or not? So this is the heat of reaction. So what is this value? So this value, heat of reaction, is delta H is, this is the element, this is the again molecule, this is the stable form. So product is 0 minus reactant. So HgO formation is given, oh this is given to you solid, minus 90.8. so minus minus plus, so you will have simply 90.8 kilojoule. So for this reaction, this is the delta H. Now you have to calculate what will the mass with this much amount of heat. So this heat is given. This is the delta H. We can also calculate delta E. So delta H is at constant pressure. Are you getting or not? So this is at constant pressure. This is at constant pressure. Are you getting? We can calculate delta E. What is the relation? We have delta H is equals to delta E plus delta NZRT. And what is the value of delta H? So I can write delta E is equals to delta H minus and delta NZRT. So what is the value of delta H? That is 90.8 in kilojoule minus delta Ng. What is the gas this side? Product side half mole, this side 0 mole. So this is half into R. R value is at 0.31 and temperature that is given in the problem 298 Kelvin. So we can calculate this value. So this will give you delta E. So let us calculate this one. So this is, so you have to do this one. So this value is 90.8 minus, so this is 90.8 minus 0.5 into 8.31 multiplied by 298, and this is in joule, so I have to divide by 1000. So this should be divided by 1000, so I will get in the kilojoule. So this value, we have to find. So this is equals to 89.56. So this value comes out to be 89.56. So this is 89.56 kilojoule. So this is the delta E. Now we have to calculate what is the mass. So let us calculate mole first and then we'll calculate mass. So mole of Hg liberated, that we have to find it out. So mole of Hg liberated at constant pressure. Let us first find this at constant pressure. So the heat given is 41.84. So this is the heat given, 41.84, and this divided by what is the constant heat, constant pressure, what is the heat, 90.8 kilojoule per mole. Are you getting? So this is divided by 90.8 kilojoule. Now if I want to find in mass, let us first find mass. I have to multiply this by molecular mass. Molecular mass is 200.6 gram per mole. So I have to multiply this by 200.6. So now I will get in gram, that is not mass. This is, now I am calculating, this is mass. So we have multiplied by molecular weight. So this value, so let us check this value. So 41.84 So this value I have to have. So this is 41.84 divided by 90.8 and this multiplied by 200.6. So this value comes out to be 92.43. So this is 92.43 gram. So this value is 92.43 gram. We can do the same thing. Mass of Hg liberated at constant volume. Mass of Hg liberated at constant volume. This time what we will have. So same thing. This is now we will have. This is at constant volume, that is 89.56. 41.84 and this divided by 89.56, this multiplied by 200.6. So what is this value? Let us calculate this one. So we will have the first term is same. So let me calculate again. 41.84, this divided by 89.56 and this multiplied by 200.6. So this value is 93.71. So this is 93.71. So now I can write this is 93.71 gram. So you can check the answer. You should have 92.43. So this is the value 92.43 and then is 93.72. 93.72. Now you see one important point you have, at constant pressure you are getting lesser mass, at constant volume you have higher mass. This should be because at constant pressure some of the amount of heat is used for PV work. Now at constant volume case, volume is constant, so no PV work. So all of the heat has gone to liberate the mass of Hg. So no PV work. This is important.